the values cos theta cos phi minus sin theta sin phi, sin theta cos phi plus cos theta sin phi. We write this one sin of alpha plus beta into cos gamma plus cos of alpha plus beta into sin gamma. Now for sin of alpha plus beta cos phi or minus sin phi, that is equal to cos theta cos phi minus plus sin. Next, cos of 75 degree, that will be written as cos of the form a plus b into a minus b. Therefore, it will be sin square theta cos square phi minus cos square theta sin square phi. Sin square theta 1 minus sin square phi minus 1 minus sin square theta into sin square phi, and we simplify, it will be sin square theta minus sin square theta sin square phi minus sin square phi plus sin square theta sin square phi. You see, these two will be cancelled. Finally, we get sin of theta plus phi into sin of theta minus phi, that will be equal to sin square theta minus sin square phi. We can now express this in terms of cos, and that will be equal to cos square phi minus cos square theta. Students are advised to deduce these identities yourselves. If you deduce these yourself, then you can memorize easily. Now, the other one, cos of theta plus phi into cos of theta minus phi. Put the values cos theta cos phi minus sin theta sin phi into cos theta cos phi plus sin theta sin phi. It will be cos square theta cos square phi minus sin square theta sin square phi. Let me write this one. Thus we get cos of theta plus phi into cos of theta minus phi is equal to cos square theta. This cos square phi is replaced by 1 minus sin square phi minus sin square theta sin square theta cos square theta sin square phi sin square theta sin square phi we have to replace this sin square theta by 1 minus cos square theta. Cos square theta minus cos square theta sin square phi minus 1 minus cos square theta into sin square phi cos square theta minus cos square theta sin square phi minus sin square phi plus cos square theta sin square phi. You see these two cancelled. Finally we get cos square theta minus sin square phi. That is cos of theta plus phi into cos of theta minus phi. Now replacing cos square theta by 1 minus sin square theta, 1 minus sin square theta minus 1 minus cos square phi. On simplification we shall get cos square phi minus sin square. These are the two forms of cos of theta plus phi into cos of theta minus phi. Next, we can deduce easily the trigonometrical ratios of sine of say alpha plus beta plus gamma, cos of alpha plus beta plus gamma. Now we are going to deduce the identity for sine of alpha plus beta plus gamma and cos of alpha plus beta plus gamma. Now alpha plus beta plus gamma, we can take alpha plus beta as one angle and gamma the other angle. Then applying the previous formula of sine of theta plus phi, sin theta cos phi plus cos theta sin phi, we write this one sine of alpha plus beta into cos gamma plus cos of alpha plus beta into sin gamma. Now for sine of alpha plus beta, sin alpha cos beta plus cos alpha sin beta into cos gamma, and for cos of alpha plus beta cos alpha cos beta minus sin alpha sin beta whole into sin gamma. After simplification we get this final one. You see it is sin alpha cos beta cos gamma plus cos alpha sin beta cos gamma plus cos alpha cos beta sin gamma minus sin alpha sin beta sin gamma. Now to get tan form, we take cos alpha cos beta cos gamma as common factor, and you see the other factor will be this one. Finally it will be cos alpha cos beta cos gamma within brackets tan alpha plus tan beta plus tan gamma minus tan alpha tan beta tan gamma. We can use therefore sin of alpha plus beta plus gamma is equal to cos alpha cos beta cos gamma, and if we use the summation sin, it will be tan alpha minus product sin tan alpha. Summation tan alpha means here tan alpha plus tan beta plus tan gamma, and product that is actually capital pi, and that this one is capital sigma. Tan alpha in this case means tan alpha into tan beta into tan gamma. Then for cos of alpha plus beta plus gamma, if we proceed similarly, then we will get this form. Cos of alpha plus beta plus gamma is equal to cos alpha cos beta cos gamma within brackets 1 minus tan alpha tan beta minus tan beta tan gamma minus tan gamma tan alpha. We can also express in short form cos alpha cos beta cos gamma 1 minus tan beta tan gamma. If we use these symbols, it will be quite easier to memorize these results. Thus, we have got different trigonometrical identities for compound angles. Putting suitable value of theta and phi, we can find also sine of theta plus phi. I call it number 1, replacing phi by 90 degree plus phi. What we get? Cos of theta plus 90 degree plus phi. Cos theta cos 90 degree plus phi minus sin theta sin 90 degree plus phi, or cos theta minus sin phi minus sin theta cos phi, or minus sin theta plus phi is equal to minus sin theta cos phi minus cos theta sin phi. Therefore, sin of theta plus phi is equal to sin theta cos phi plus cos theta sin phi. Thus, we have deduced the sine ratio of the compound angle theta plus phi. Now, these are for general theta and phi. That means theta may be acute, theta may be obtuse, phi may be acute, phi may be obtuse. This is general deduction. In case of theta phi, both are positive acute and the sum is also acute. We have another geometrical proof. Interested students or learners can deduce yourself. Now, we just sum up. What we have deduced: number 1, cos of theta plus phi, cos theta cos phi minus sin theta sin phi. Number 2, sin of theta plus phi sin theta cos phi plus cos theta sin phi. As these are identities, we can replace phi by minus phi, so that we will get cos of theta minus phi that will be equal to cos theta cos phi plus sin theta sin phi. Number 4, sin of theta minus phi sin theta cos phi minus cos theta sin phi. Also we can express 1 and 3 in combined form. That means cos of theta plus minus phi, that is equal to cos theta cos phi minus plus sin theta sin phi, and sin theta plus minus phi, that is equal to sin theta cos phi plus minus cos theta sin phi. Now after deduction of sin of theta plus phi and cos of theta plus phi, we can now reduce tan of theta plus phi. That is not geometrical, of course. Tan of theta plus phi, according to the formula tan theta is equal to sin theta by cos theta. We can apply here sin of theta plus phi divided by cos of theta plus phi. Now we put the expressions sin theta cos phi plus cos theta sin phi by cos theta cos phi minus sin theta sin phi. Now to get tan form, we divide the numerator and denominator by cos theta cos phi, so that we get, after simplification of course, it will be tan theta plus tan phi 1 minus tan theta tan phi. Tan of theta plus phi. Similarly, we can reduce tan of theta minus phi, that will be tan theta minus tan phi divided by 1 plus tan theta tan phi. Tan of theta minus phi will be equal to tan theta minus tan phi 1 plus tan theta tan phi. Thus we have reduced the identities sin of theta plus phi, cos of theta plus phi, tan of theta plus phi, sin of theta minus phi, cos of theta minus phi, and tan of theta minus phi. Now where to apply? For that, we take few examples. To find the values of sin first sin 105 degree. Now 105 degree can be written as sum of 60 degree and 45 degree. That means sin 60 degree plus 45 degree. And as per identity we have learned This is equal to sin 60 degree cos 45 degree plus cos 60 degree sin 45 degree. Now put the values: 3 by 2, 1 by root 2 plus half 1 by root 2. After simplification, it will be 2 root 2 root 3 plus 1. Therefore, sin. Next, cos of 75 degree, that will be written as cos of 30 degree plus 45 degree. Now, this is equal to, as we have learned, cos 30 degree cos 45 degree minus sin 30 degree sin 45 degree. Putting the values: 3 by 2 into 1 by 2 minus half 1 by 2, that means root 3 minus 1 by 2. Therefore, cos of 75 degree equal to root 3 minus 1 by 2. Thus, we have applied the concept of trigonometrical ratio of compound angles. Now, let us find the value of tan 15 degree. Now, 15 degree can be written as 45 degree minus 30 degree. Also, you can take 60 degree, 45 degree also. Now, we apply the formula. Now, put the values: 1 minus 1 by root 3, 1 plus 1 into 1 by root 3. Simplify, it will be root 3 minus 1 root 3 plus 1. Thus, tan 15 degree is equal to root 3 minus 1 root 3 plus 1. Thus, we have applied the concept of finding trigonometrical ratios of compound angles. In case of 105 degree, the angle is written as sum of 60 degree and 45 degree. In case of 75 degree, we have written 75 degree as sum of 45 degree, 30 degree, and for 15 degree, we have written that angle as difference of two angles, that is 45 degree and 30 degree, and got the values of sin 105 degree, cos of 75 degree, and tan of 15 degree. Now, we can combine the identities of